Hi, welcome to Section 3, Lay Them Out. In this section, we'll take a look at building a pie chart, a stacked area chart, a tree map, a tree, and an enclosure diagram. Now, we move on to the first video of this section that deals with building a pie chart. In this video, we will explore techniques involving D3 pie layout to build a fully functional pie chart. A pie chart, or a circle graph, is a circular graph that contains multiple sectors used to illustrate numerical proportion. We will explore techniques involving D3 pie layout to build a fully functional pie chart. The D3 arc generator directly is a very tedious job. Each arc generator expects this data format. This essentially requires the calculation of the angle partition for each slice out of an entire circle of 2 pi. Obviously, this process can be automated by an algorithm, which is exactly what D3 pie is designed for. Let's see how a pie layout can be used to implement a fully functional pie chart. First, open your local copy of this file in your favorite text editor. A pie chart, or a circle graph, is a circular diagram divided into sectors. Pie charts are popular in many fields and widely used to demonstrate relationships between different entities, though not without criticism. Take a look at how a pie chart is implemented using D3 layout. The code generates a pie chart. Here it is. We rely on D3 pie to transform the raw data into arcs data for us. The pie layout was created on line A with both sort and value accessors specified. The sort function tells the pie layout to sort slices by its ID field, so that we can maintain stable order among slices. Without the sorting, by default, the pie layout will order the slices by value, resulting in the swapping of slices whenever we update the pie chart. The value function is used to provide value accessor, which returns the value field. When rendering slices, now with the pie layout, we directly set the output of the pie function call as data remember. Layouts are data to generate the arc SVG path elements on line B. At this point, you might be wondering what kind of data D3 pie generates. As we can see clearly, this is exactly what the D3 arc generator expects. This is why we can use this data directly with D3.arc without dealing with any detailed calculation for angles and partitions. We retrieve the current arc value from the element, so the transition can start from the current angle instead of 0. Then, we reset the current arc value to the latest one, so the next time when we update the pie chart data, we can repeat the stateful transition. Finally, we also need to render labels on each slice to understand what each slice is representing. This is done by the render labels function. Once again, we use the output of the pie function call as data to generate the SVG text elements. The placement of the labels is calculated using arc centroid on line F. Additionally, the label placement is animated through the transition so they can be moved with arcs in unison.